As we all know that as the exam date approaches, anxiety will set in. So what you need to do now is to focus on those questions that JAMB cannot avoid. That is, JAMB cannot do without this particular question. So in this video, I'm going to lead you through those questions that JAMB cannot do without, JAMB cannot avoid. You must see it in this particular exam. So in case you see it or something similar to it, and remember that they always change digits, that is values in a particular question. The previous one must be 10 centimeter, but in this one they can just change to what 15 or 20, but still the same question. With no further ado, let's get right into the video. Metal rods of length 20 meters each are laid end to end to form a bridge at 25 degrees Celsius. What gap will be provided between consecutive rails for the bridge to withstand 75 degrees Celsius? Okay, so we are given the linear expansivity of the material to be 2.0 times 10 to the power of minus 5 per Kelvin. So we have the following options. Option A, 0.22 meters. Option B, 0.25 meters. Option C, 0.02 meters. Option D, 0.20 meters. Now, this particular question is talking about linear expansivity. So what is linear expansivity? Linear expansivity is the increase in length per unit length per degree rise in temperature. So now alpha, which is the linear expansivity, is given by alpha is equals to L2 minus L1 all over L1 theta. Okay, now from the question, what are we looking for? And the definition says that linear expansivity is defined as the increase in length per unit length per degree rise in temperature. So if I am to state it the way they define it, you're going to see what you're actually looking for. That is, alpha is equals to increase in length. All over original length times temperature rise. Do you get it now? But the question says we are looking for increase in length. That means our increase in length is this one that we are looking for. So from the formula, our increase in length is what? L2 minus L1. I hope you understand. So increase in length is change in the length. That is L2 minus L1. So let's go. So that is alpha is equals to the change in the length all over L1 what? Theta. So what you're looking for is the change in the length. So if you want to make it the subject, simply by saying cross multiply, okay? Now this is over 1. I can say cross multiply. The change in the length is equals to L1 theta what? Alpha. This L1 is the original length. Theta is the change in temperature, while alpha is the linear expansivity. Hope that is clear. So let's substitute into what we have so we can get our answer. Question says metal rod of length 20 meters. That means my L1, which is the original length of the rod, is 20 meters. So I will go by saying L1 is equals to 20 meters. The first temperature was given as 25 degrees Celsius. So theta 1 is 25 degrees Celsius, okay? And theta 2 is 75 degree what? Celsius, right? And we're given alpha as 2.0 times 10 to the power of minus 5 per Kelvin. Now from what we have now, we can just get the change in temperature, which is theta what? Delta theta, right? Which is going to give me 75 minus 25 is going to give me 50 degree Celsius as my change in temperature. Okay, so let me just substitute by multiplying these three things to get my change in the length. So let's go. So delta L is equals to L1 theta alpha. So my L1 is 20 multiplied by my theta is 50 multiplied by my alpha is 2 times 10 to the power of minus 5, right? Now, by the time you multiply, it's going to give us 0.02 meters. So that is the change in the length. And the examiner can still change this question into another English. It's as if it's a different thing, but this is what they want you to calculate. Aside from telling you the increase in length, they can say it to be what? Change in what? Change in length. Okay? They can call this what? Thermal expansion. Okay? They can call it what? Safety gap. Safety gap. All these three things, they all mean the same thing. So even if you did not see change in the length or increase in length, it's still the same thing as what? Change in length, thermal expansion, or safety gap. They all mean that you should calculate the change in length. Do you understand? Okay, so in case you did not see it in this way I just solved it, and you saw it in another pattern, which is this English that they used, you are asked to find the increase in the length. Do you understand? What we've got so far, the correct option to this question is option C. The temperature gradient across a copper rod of thickness 0.02 meters maintained at two temperature junctions of 20 degrees Celsius and 80 degrees Celsius respectively is what? Option A, 3.0 times 10 to the power 2 Kelvin per meter. Option B, 3.0 times 10 to the power 3 Kelvin per meter. Option C, 5.0 times 10 to the power 3 Kelvin per meter. Option D, 3.0 times 10 to the power 4 Kelvin per meter. This question is quite simple. The question says you should calculate the temperature gradient. And for you to get the temperature gradient, it is the change in temperature divided by what? Length. It's as simple as that, okay? So let's go. Temperature gradient is equals to the change in temperature, which is theta, divided by what? The length. Okay, now from the question we have two different temperatures and the length, so let's state it out. The length is given as 0.02 meters. Okay, the first temperature is given as 20 degrees Celsius, that is theta 1 is equals to 20 degrees Celsius. Theta 2 is 80 degrees Celsius. So you can now get the temperature gradient. So let's solve. The temperature gradient is equals to, the change in temperature is what? Theta 2 minus theta 1, right? Divided by what? The length. Is that clear? So by substituting into what we have, I have my theta 2 to be 80 minus 20 divided by what? 0.02. Okay, now this is going to give me 60, because 80 minus 20 is 60 divided by 0.02. all right, so by the time you divide, it's going to have 3000 Kelvin per meter, right? But because the question left it in standard form, so you're going to take it up by saying this is what? 1 to what? 3. So this is 3.0 times 10 to the power of what? 3 Kelvin per meter. Do we understand? So this is how to solve this type of problem. This particular one is quite simple, but if you don't know the formula to use, you'll be like the question is very, very what? Difficult. From what we've got so far, the correct option to this question is option B. A parallel plate capacitor has a common plate area of 5 times 10 to the power of minus 8 per meter square and plate separation of 2 times 10 to the power of minus 3 meters. Assuming free space, what is the capacitance? We are given epsilon 0, that is a constant, as 9.0 times 10 to the power of minus 12 coulomb square per Newton per meter square. We have the following options. Option A, 2.25 times 10 to the power of minus 17 farad. Option B, 4.50 times 10 to the power of minus 17 farad. Option C, 2.25 times 10 to the power of minus 16 farad. Option D, 4.50 times 10 to the power of minus 16 farad. Now, this particular question is under the factors that affect the parallel plate capacitors. And these factors are, we have the area of the plate, we have the distance between the plates, and the dielectric constant. So it is these factors that we use to form this particular equation that we are going to use to solve this problem. So this equation of a parallel plate capacitor is given by C is equals to epsilon 0A over what? D, right? So this is what? The capacitance of a capacitor. This is the permittivity of free space. This is what? The area, and this is what? The distance between the plate. Is that clear? So let us state the parameters we have so that we can see how we can solve the capacitance of the capacitor. The area is given as 5 times 10 to the power of minus 8 meters squared. So let's go. We have A is equals to 5 times 10 raised to the power of minus 8 meters squared. That's my area, right? And the distance which separates the plate is given as, that is D, equals 2 times 10 to the power of minus 3 meters. Okay? Now we are given that constant, which is permittivity of free space, is equals to epsilon 0, 9.0 times 10 to the power of minus 12 half coulomb square per Newton per meter square. So that is the value of this permittivity of free space. So what you are going to do is just to substitute into what we have, and we see our answer smiling. So let's go. So the capacitance of a capacitor is equals to, what's my epsilon 0? I have 9 times 10 to the power of minus 12 times, what's my area? 5 times 10 to the power of minus 8. Now divided by, what's my distance? I have 2 times 10 to the power of minus 3. Are we clear now? So let's work it out and see what we have. Now, even without using calculator, you can just use our brain and see if you can actually do this multiplication. So let's go. 4 multiplied by 5 is going to give me 45. So I'm going to say this is 45 times 10 to the power of, this is minus 12 minus 8, right? So this is minus 12 minus 8, which is give rise to what? Minus 20. I hope that is clear. So I will now say minus what? 20 divided by, this is 2 times 10 to the power of minus 3. So what I need to do now is to use this 2 to divide 45. Then I have to carry this minus 3 to the numerator so that the sign will just change to what? Plus or positive. Okay, so let's go. Let's go by saying 45 divided by this is going to give me what? 22.5 times, this is 10 power what? Minus 20 times 10 power minus, plus 3. So my C is equals to, I have 22.5 times 10 power. So let's go. This is minus 20 plus 3 is going to give me what? Minus 17, okay? So this is what? Minus 17. But because I want this power to do what? To come over to this place. So I'm going to go what? 1 backward. I'll count 1. So when I count 1, I'm going to reduce 1 from the power. So this is going to be what? 2.2 times 10 to the power of minus 16 farad. Is that clear? Now, this is how to solve this kind of problem, even without using calculator. And you can actually solve it in less than a minute. Very much possible. And from what we've got so far, the correct option to this question is option C. A cell can supply current of 0.4 amperes and 0.2 amperes through a 4.0 ohms and 10.0 ohms resistors respectively. The internal resistance of the cell is what? Option A, 2.0 ohms, option B, 1.0 ohms, option C, 2.5 ohms, option D, 1.5 ohms. Now this question is talking about a cell supplying current through a resistor. That is going to supply current through 2 different resistors. Okay, when it supplies current with this resistor, it's going to supply another current with another what? Resistor. So it asks to find the internal resistance of this particular what? Cell. So what that will come to your mind is this. What is internal resistance? Internal resistance is the opposition to the flow of electric current offered by the what? The poles of the cell. Now you know that a cell, a cell means battery, not just be plain. A cell means battery. So the EMF of a particular cell, that is one cell, is 1.5 volts. But if you do your connection with a battery to do an experiment, you realize that the EMF will be less than 1.5 volts. Okay? Then why is this so? It's because of what? The internal resistance of this cell. It has made it to do what? To reduce. Do you understand? So that is what we're actually looking for in this particular question. So let's proceed. We're going to be stating the two current that was passed through these two resistors so we can see what we're actually looking for. So let's go. We have the current 1, which is I1 equals 0.4 amperes. Okay. Now I2 equals 0.2 amperes, right? Then the external resistance, which is what? Big R, that is the first one, is equals to 4 ohms, right? Then the second resistance is equals to 10 ohms. So we're looking for the internal resistance, which is what? Small r. Do you understand? So this is external. Why this is what? Internal resistance. And the first thing that will come to your mind is this, that the EMF of a cell, E, is equals to, this is E, is equals to, this is called terminal PD plus lost volt. Okay, so if I explain further, I'll have this terminal PD is equals to I what? Big R. Then the lost volt is equals to I small what? R. So if you are to put it into this equation, you are going to see how to solve our internal resistance. So let's just get this formula straight before we can solve. Okay, now the EMF E is equals to, what's my terminal PD? I have what? I what? Big R, right? Then plus, what's my lost volt? I have I small what? R. Now something is common, so E is equals to I, which is the current, bracket I plus what? R. Is that okay? Now this is the formula we are going to use to solve this particular problem. Okay, but in case you are asked to calculate the current flowing through a particular circuit, you have the internal and external resistance. You are going to use this particular one, okay, by making it the subject, which is by saying that E all over R plus what? R. Is that okay? So this and this, they are all what? The same, depending on what you are looking for. So I'm going to use this particular equation to solve this problem on the board. I hope that is clear. Now, by stating our formula, we're going to say that I, okay, is equals to E all over what? R plus what? R, right? But if you're looking for the first current, that is I1, you're going to say what? I1 is equals to E over R1 plus what? R. Is that clear? What's my I1? I have 0.4 is equals to E over R plus what? R. So if you say that this is over 1 and say cross multiply, okay, therefore my E is equals to 0.4 bracket my big R, which is R1, is what? 4 plus what? Small r. Now similarly, if you do it for the second one, which is I2, you're going to have what? That E is equals to what? 0.2 bracket 10 plus what? R. So we are going to equate the two to get the unknown, which is the internal resistance. So let's solve. Now we'll go by saying this is 0.4 bracket 4 plus R is equals to 0.2 bracket 10 plus R. Okay, now let's work it out. 0.4 times, so it's going to give me what? 1.6 plus 0.4 times R, that is 0.4 R, is equals to, when you multiply this, what do we have? I'm going to have 2 plus 0.2 R. Do you understand? Let's proceed by collecting like terms, okay, which is I have 0.4 R, okay, minus 0.2 what? R is equals to 2 minus 1.6. Okay, by the time you subtract, you're going to have 0.2r is equals to what? 0.4. So we divide both sides by 0.2, 0.2. Okay, this cancels this. I am left with what? R. So 0.4 divided by 0.2 is going to give me what? 2 ohms, right? Now this is the answer to this particular question. I took my time to explain it so that even if you see something similar to this, like finding the lost volt or like finding the terminal PD, you can solve it with that formula I gave you. Now from what we've done so far, the correct option to this question is option A. A conductor has a diameter of 1.00 millimeters and length of 2.00 meters. If the resistance of the material is 0.1 ohms, its resistivity is what? We have the following options. Option A 3.93 times 10 to the power of minus 8 ohm meter. Option B 3.93 times 10 to the power of minus 6 ohm meters. Option C 2.55 times 10 to the power of 2 ohm meters. Option D 2.55 times 10 to the power of 5 ohm meters. In solving this problem, we must remember that there are factors that affect the electrical resistance of a wire. We have what? The length of conductor, the area of conductor, the temperature and type of material. Okay, so let's bring them together to form this equation that we're going to use for this resistivity. So let's go. We have that the resistance varies directly as the length. The resistance varies inversely as what? As the area, right? If you bring them together, there can be a joint variation by saying that what? The R is proportional to L and inversely what? To A, right? Now, if you remove this proportionality sign, we're going to introduce a constant, because in every proportionality sign in physics, we must introduce a constant, and that constant has meaning and unit. So let's go. We say that this is what? R is equals to rho L over what? A. Okay, now if we say this is over 1, we want to make this constant the subject, which is resistivity that we are looking for, by saying cross multiply rho L is equals what? RA. Okay, so we divide both sides by what? By L. So this is what? L. So this cancel out, therefore rho is equals what? RA over what? L. So this is the formula that we are going to use to solve this particular question. I hope that is clear now. What about the unit? Now, resistance is measured in ohms, area is measured in meter square, and length is measured in what? Meter. So by the time this cancels this, so unit of rho, which is resistivity, becomes ohm meters. I hope that is clear. So we're going to state our parameters to solve this particular problem. So let's go. So let us state all the parameters we have in this particular question. We are given the diameter of 1.00 millimeters. So let's go. I have diameter D is equals to 1 millimeters, right? The length is given as 2 meters. So L is equals to 2 meters, right? Then the resistance is 0.1 ohms. Resistance R is 0.1 ohms. Okay. Now, how do we find the resistivity, which is rho is equals to what we are looking for? But we don't even have area. So we're going to get area from this diameter because they are related. Knowing that area is equals to pi r what? Square. Okay. Well, do we have radius? No. We can just get radius from our what? Diameter. Because the radius is diameter over what? 2. That is 1 over what? 2. Okay. So my R is equals to 0.5 millimeters. Right? Is that clear? But we can't solve with our radius in millimeters because the length is in meters. So we're going to do what? We're going to convert to meters simply by doing what? Dividing by 1000. Is that clear? So let's go. So we have that my radius is equals to 0.5 divided by 1000. Okay. Now this is equals to 5 times 10 to the power of minus 4 meters. As my radius, I've not yet gotten my area. So let's solve for the area. So my area A is given as pi r what? Square. My pi is 22/7 or 3.142. So let's go. So this is 3.142 times my radius is what? 5 times 10 to the power of minus 4, okay? Squared. I hope that is clear. Now work it out by saying that this is 3.142 times, by the time I square this, I'm going to have 25 times 10 to the power of minus 8. Okay, so this is my what? Area. So let me work it out to see what I have. So it's going to give me 7.855 times 10 to the power of minus 7 meter squared. This is just my area. So now I can now solve my resistivity. So let's go. My resistivity rho is equals to RA over L, right? What's my R? My R is 0.1 multiplied by 7.855 times 10 to the power of minus 7 divided by my length is what? 2. So let's work it out by saying that this is going to give me 7.855 times 10 to the power of what? Minus 8 and divided by what? 2. And the answer will now be equals to, the answer is equals to 3.93 times 10 to the power of minus 8 ohm meter. So this is 3, right? Okay. Is that clear? Now this is how you can solve this problem on resistivity. In case I ask to find conductivity, conductivity is the inverse of what? Resistivity. Simply by saying that this is what? Conductivity is equals to 1 over what? Resistivity. So as I've gotten this now, just say 1 over or reciprocal of this is going to give you what? Conductivity. Is that clear? And the unit of conductivity becomes per ohm per meter. I hope that is clear. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see it and learn from there. I'll see you next time in the next episode. Bye for now.